In this video, we will learn about mole. Uh, uh, no, not these moles. We will learn about the mole which is used in chemistry. So the word mole was introduced by Wilhelm Oswald in 1896, and the word means heap or pile. 1 mole is the amount of a substance that contains 6.022 into 10 raised to 23 atoms or molecules, or it can be ions or electrons, it can be anything. Say for example, if I have 100 grams of a substance A, I'm just taking a random example. We have 100 grams of substance A, and this 100 grams contains 6.022 into 10 raised to 23 particles. Now, what particles? That depends on A. If this A is an element, then it will be atoms. If this is a compound, then it will be molecules. So if I have 100 grams of a substance, and if it contains these many particles, that means this 100 gram is representing 1 mole of A. It is representing 1 mole of A. Let us understand how to find out exactly how many grams will contain these many particles. So scientists count atoms and molecules by weighing them, because we know atoms are and molecules are very small. So even in if I have 1 gram of something, it will contain large amount of atoms. So it's very difficult to count them. So easier way is to weigh the substance. Now, what scientists have found out experimentally is when you weigh an element equal to its atomic mass, it will contain 6.022 into 10 raised to 23 atoms. Okay, let us understand by taking an example. If I have magnesium with me, I'm taking an element, magnesium. Atomic mass of magnesium is 24. I need to express it in grams. So if I take 24 grams of magnesium, it will contain 6.022 into 10 raised to 23 atoms. And just now we studied that any mass that contains these many atoms, that is equal to 1 mole. That mass is equal to 1 mole. So when I say 24 grams of magnesium, I'm actually saying 1 mole of magnesium, because that 24 grams contains these many atoms, and this has been found experimentally. Now same applies for compounds. So if I have a compound, and if I take the compound equal to its molecular mass, if I take compound equal to its molecular mass and express it in grams, then it will contain these many atoms. For example, if I take water, let us first find out the molecular mass of water. 2 atoms of hydrogen, atomic mass of hydrogen is 1, plus atomic mass of oxygen is 16, so it is 18. Molecular mass of water is 18. So if I take 18 grams of water, it will contain 6.022 into 10 raised to 23 molecules, which means this 18 grams is nothing but 1 mole. So if you have a compound, you need to take the molecular mass in grams. If you have an element, you need to take the atomic mass in grams. That will contain 6.022 into 10 raised to 23 atoms or molecules, and it will be equal to 1 mole. Now in these two examples, we can clearly see that 1 mole is actually linking the mass and the number. The mass and the number is linked. So that is what mole does. It gives us a link between mass of the atoms and number of the atoms. This number 6.022 into 10 raised to 23 is called as Avogadro's constant or Avogadro number, represented by Na or N naught. A, and that's not 0, is subscript. You need to be very careful with that. So 1 mole of any substance contains Avogadro number of particles, and as I said earlier, it has been found out experimentally. This constant is named as Avogadro in the honor of Italian scientist Amedeo Avogadro. Let us take more examples and understand how mole, mass, and number is linked. Let us fill up this table so that we can compare and understand. I need to write the symbol for hydrogen atom, hydrogen molecule, ammonia molecule, NH3, sodium atoms, Na. Mass of 1 mole or mass of one molecule is referred to as molar mass. So whatever we have calculated previously, water we calculated, it was 18 grams. That is nothing but, that is molecular mass of water, which is also called as molar mass. So molar mass, molecular mass, they can be used interchangeable. They are interchangeable. So for hydrogen, if I have 1 mole of hydrogen, since it is an element, we are talking about element, I need to write atomic mass of hydrogen here in grams. It is an element, I need to write atomic mass. Atomic mass of hydrogen is 1. So 1 gram. I'm talking about molecule here. In the second case, it is H2. H2 means 2 into 1 because I have 2 hydrogen atoms there. So molecular mass of H2 will be 2 grams. In case of ammonia, the molecular mass will be, let's calculate, 14 is the atomic mass of nitrogen. Each hydrogen has a mass of 1, so 3 into 1, so that is 17. So it is 17 grams. Sodium again is an element, so I need to write its atomic mass, that is 23. So we have found out the molar masses depending on whether it is an element or whether it is a compound. These are compounds, the other two are elements. Now let us see how many atoms or molecules they contain. Now since this is first one, hydrogen is an element, it contains 6.022 into 10 raised to 23 atoms. It is 1 mole. This number does not matter now. We are talking about this mole. It is 1 mole of hydrogen, so it will contain Avogadro number of atoms. 1 mole of hydrogen molecules, so it will have 6.022 into 10 raised to 23 molecules. I have 1 mole of ammonia molecules. That means I have Avogadro number of molecules. And in the last case, I have 1 mole of sodium atoms. So I will have Avogadro number of atoms. If you notice, this part is changing. the mass changes, whereas the number of atoms does not change. That is, whenever I say 1 mole, it is Avogadro's number. It is Avogadro's number. Atoms or molecules, it depends what you have, whether you have an element or you have a compound. So when I say 1 mole, what is constant? Avogadro's number is constant. 6.022 into 10 raised to 23. Atoms, molecules, that depends. But the mass changes. The mass changes based on what element or what compound you have. It is similar to this example what I'm giving now. If I say 1 dozen, we know it is 12. But the mass may not be the same. It depends on what we have. If I have 1 dozen of bananas, the mass will be different compared to 1 dozen of grapes. Obviously, both of them will not have equal mass, but in both the cases we have same number. We have 12 bananas and 12 grapes because it is 1 dozen. The number is the same, but the mass is different. Same thing here. Whenever we say 1 mole, the number will be the same, but the mass will differ based on what we have.